the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Hello and welcome, my wonderful listeners, viewers and learners at home. Once again, you are welcome to the Kaduna State Ministry of Education e-learning platform. On our subject chemistry today, I will be discussing a very interesting topic, and it's the topic Law of Chemical Combination and Chemical Equations. Before I move further, my name is Mr. Philip Mamman. I'd like you to know that the chemical equation is a very important aspect of chemistry. It's the language we use in writing chemistry. Today we'll be looking at the law of chemical combination. Of course, we have seen this previously when we are discussing chemical combination. I'll just throw some highlights on it, as our emphasis today will be on chemical equation and balancing of chemical equations. Looking at the introduction, the laws of chemical combination such as constant composition, multiple proportion and reciprocal proportion were discovered experimentally by a lot of scientists. But this concept were not properly understood until John Dalton propounded his postulates. And these postulates includes matter is made up of small particles called atoms. Chemical reactions take place between small whole number of atoms. And of course, atoms of the same elements are alike, even though these postulates have been modified as we have seen in our previous lessons. These laws of chemical combination include law of conservation of mass, law of constant composition or law of definite proportion. Then we have law of multiple proportion, and finally law of reciprocal proportion. All these make up law of chemical combination. I'll start by looking at the law of conservation of mass. Now, this law was propounded by a French chemist, Antoine Lavoisier, in 1783 to 1794, and he was regarded generally as the father of modern chemistry. And the law states that, the law of conservation of mass states that matter is neither created nor destroyed during a chemical reaction. This means that in a chemical reaction, the mass of the reactant is usually the same as the mass of the product at the end of the chemical reaction. And you can see this illustrated by this diagram. You can see that this reaction is taking place. There are two reactants there, and the mass there is the same as 67.725 grams. And after this reaction has taken place, it was still recorded that the mass of the product was still 67.25 grams, meaning that there is no loss of mass during this chemical reaction. It's the basis of balancing of chemical equation, as we are going to see as these lessons proceed. The law of composition, constant composition or definite proportion. This law of definite proportion says that all pure samples of a chemical compound contain the same element combined in the same proportion by mass, meaning that when elements combine to form a compound, the proportion of this element by mass is the same. The theory is based on the fact that when elements combine to form compounds, they do so in fixed proportion by mass. That's why in water you have H2O. That H2 is constant, and that one O is also constant. As you can see it, this means that all pure samples of a particular chemical compound are identical, irrespective of their sources. Regardless of what the source of water is, it will always be H2O. As you can see here, we have other like NO, we have NO2, and so on and so forth. Now, the law of constant composition, you can have nitrogen and oxygen forming different compounds, like nitrogen-2 oxide, NO, which is a colorless gas, or nitrogen-4 oxide, which is nitrogen dioxide, which is the same thing as NO2, which is a reddish brown gas. And you can have nitrogen-1 oxide or dinitrogen 1 oxide, which is N2O, which is also a colorless gas. You can have other examples like copper 1 and copper 2 oxides, as the case might be. In each of these cases, the masses of the element that combine to form this compound are fixed in a proportion. Then the law of multiple proportion. The law of multiple proportion states that if two elements A and B combine to form more than one compound, the variable mass of B, which combine with the fixed mass of A, are in simple multiple or numerical ratio. This means that the variable masses of B and the fixed mass of A will be in a simple ratio. As you are going to see, there are so many examples that explain this concept, and these examples are in the case of water, where 2 atoms of hydrogen with a mass of 2 grams combine with 1 atom of oxygen with a mass of 16. So the ratio is 2:16. And if you come to carbon 4 oxide, where 12 grams of carbon combines with 2 atoms of oxygen, which is 32, you have a ratio of 12:32. This concept explains the law of multiple proportion, as has been illustrated by this diagram. My wonderful students, I'm sure that you are correlating what we are saying today with what we have said in our previous lesson. Law of reciprocal proportion. The law of reciprocal proportion states that if an element A combines separately with several other elements B, C, D, the masses of B, C, and D, which combine with a fixed mass of A, are the same as the masses of B, C, and D when they combine with one another or in their simple numerical ratios. Now you will see this in a chart. For instance, in methane and water, carbon 4 oxide, for instance, in methane, water and carbon 4 oxide. In methane, carbon is 1 atom, which is 12 grams, combining with 4 hydrogen, which is 4 grams, so that you have 12:4 in ratio. Then you will see that I just gave a simple diagram here to help you correlate this relationship. You see that hydrogen is separate, sulfur is separate, and oxygen is separate. When oxygen combines with hydrogen in H2O, the mass is 16. But when oxygen combines with sulfur, you find that there are 2 atoms of oxygen to make it SO2. But when hydrogen combines with sulfur, it gives you H2S. Now, this is what the law of reciprocal proportion is talking about. My wonderful students, like I said today, my emphasis on the lesson will be on chemical equation. And like I say, chemical equation is the language of chemistry. You find out that a chemical equation is a shorthand, an accurate way of writing a chemical reaction. It involves the use of symbols and formulae of atoms, molecules, and ions to indicate new substances that react, which are called the reactants, and the new substances that are formed, which are called the product. Now, in this equation, the equation represents so many information. It tells us a lot of things, and some of the information include reactant and product. For instance, in the formation of water, you know that the reactant is hydrogen, and oxygen, and the product is eventually water. Then it also tells us whether the reactant is reversible or irreversible. The type of arrow on the equations tells you whether the reaction is reversible. For instance, 2 half-headed arrow, one pointing forward and the other pointing backward, shows that it's a reversible reaction. But if a reaction has only 1 arrow facing one direction, it means that the reaction is irreversible. Whether a reaction is exothermic, as in the case of delta H, is negative, or the reaction is endothermic, as in the case of delta H, is positive. The equation also tells us the physical state of reactant and product. As you can see, S is for solid, AQ is for aqueous, G is for gas, and L is for liquid. All this information and many more will tell us when we have an equation that is properly written. Of course, it will tell us the condition necessary for that reaction to occur, whether there is need for heat, whether there is a catalyst, and so on and so forth. As we proceed, you will see what we mean by this. In a chemical reaction or equation, reactants are usually placed on the left-hand side, which is LHS, while the products are placed on the right-hand side, which is RHS. Using a word equation, for instance, I want to use a word to describe an equation, or words to describe equation. I say calcium plus water to give you calcium hydroxide and hydrogen. You can see that the reactant is on the left-hand side and the product is on the right-hand side. Now, you see, using formulae, you find out that instead of calcium, I'll use Ca, which is the symbol of calcium, and the physical state of calcium, that is calcium, is in solid state. Then H2O for water, which is in liquid state. Then calcium hydroxide plus hydrogen. Now, another information you get from this chemical equation is the mole ratio of both the reactant and the product. What you have here is 1 mole reacting with 2 mole of water to give you 1 mole of calcium and 1 mole of hydrogen. We refer to that as the mole ratio of both reactant and product. In writing a chemical equation, we must use the correct symbols and formula of atoms or molecules. Very, very important, because that will send the right message to whoever is reading this equation wherever in the world. We must also know the type of reaction to give the correct reactant and product. Also very important, students must know the type of reaction that is taking place. I'm going to take time out to give you the different type of chemical reactions that you are likely to come across. I will say before writing chemical equation, you must know the type of reaction. This will help you to predict the correct reactant and product of the unknown reaction. Now, some of the very common reactions include direct combination of elements. When element A combines with element B, it gives you AB. Example, sodium combining with chlorine will give you sodium chloride, as you can see in this equation. In other words, when we say decomposition reaction, in decomposition reaction, it means one chemical compound will break down to give you 2 or more other chemical compounds, as the case may be, so that you can see that AB reacting to give you A plus B. As in the case of magnesium hydrogen triazocarbonate 4, decomposes to give you magnesium triazocarbonate 4 plus water plus carbon 4 oxide. So if a reaction is decomposition, you know what the product is likely to be. Calcium will give you calcium triazocarbonate 4 will react to give you calcium oxide plus carbon 4 oxide. As you can see, the physical states of this reactant and product are clearly stated in my reactions. Now, the next one is displacement reaction. From the word displacement, it means replacing a particular element from a particular compound, such that if A reacts with BC, and the tendency that BC is superior to A is superior to B based on activity series or any other condition, it is likely to displace B and take the position of B, and you have a product as AC plus B. As in the case of when metals like magnesium react with copper 2-triaugonitrate 5, it gives you magnesium triaugonitrate 5 plus copper. You can see that magnesium is above copper on the electrochemical series, so it has a tendency of displacing copper in copper triaoxonitrate 5, so that it becomes magnesium triaoxonitrate 5, and copper will be deposited. Or you can see also zinc react with an acid. Any metal that is above hydrogen on the electrochemical series have the tendency of displacing hydrogen in an acid, so that zinc displaces hydrogen to give you zinc chloride plus hydrogen gas that will be liberated. Then double decomposition. As the name implied, it means that the two elements or the two compounds involved in the reaction will decompose and eventually exchange their cations and anions. As you can see in this case, AB plus CD eventually giving you AD plus CB. If you look at it here, you see that potassium iodide plus lead 2-triaugonitrate 5. You see that the triaugonitrate 5 goes to potassium and the iodide goes to lead. So you have potassium triaugonitrate 5 plus lead iodide. Or in the case of carrying out analytical tests in the laboratory, you find that certain precipitates are formed because of insoluble salt that is produced. This insoluble salt, as a result of double decomposition, as silver trigonnitrate 5 will react with sodium chloride to give you an insoluble silver chloride plus sodium trioxonitrate 5. My wonderful student, there are so many other equations and reactions that you must know. When we say combustion in chemistry, we mean burning. In a reaction in which substance react with oxygen gas, releasing energy in form of light and heat. So you can see that oxygen is important in combustion. And that's why you can see hydrogen plus oxygen to give you water, or propane plus oxygen to give you carbon dioxide and water. You must know that all hydrocarbons burn in air to produce carbon dioxide and water. Then of course, this very popular reaction, neutralization reaction, the reaction between acid and base to give you salt and water only. As you can see, tetraosulfate 6 acid plus potassium hydroxide to give you potassium tetraosulfate 6 and water. Now, this last two reactions I'm going to tell you is about is when you come across them in your organic chemistry. Addition reaction, like the name implies, is just adding. If you see there is ethyne C2H2 plus hydrogen. You can see that there are 2 moles of hydrogen there. Now, C2H2, if you add 4 hydrogen as the case might be, it becomes C2H6. That's what we mean by addition reaction. But when we say substitution reaction, just like in a football match, when you want to replace a player, you must bring out one player and introduce another. So as this case, you can see that methane is CH4 plus 4 moles of chlorine. It gives you CCl4. All the 4 hydrogens have been replaced by chlorine, and that's why it's called substitution reaction. Finally, my students, the main thing you must put emphasis on is how to balance a chemical reaction. Like I said, it's based on the law of conservation of mass. Atoms can neither be created nor destroyed during a chemical reaction. What it means is that every atom on the left-hand side must be equal to the atom on the right-hand side. So a balanced chemical equation is based on the law of conservation of mass. An equation is said to be balanced when the number of atoms of element in the reactant side equal to the product that on the product side. Balancing a chemical equation is a process of trial and error. You will try as many times as possible until the equation is balanced. I'll give us some very simple examples. You can see water decomposed to give you hydrogen and oxygen. This reaction is unbalanced. Why? Because on the reactant side there are 2 hydrogen, and on the product side there's also 2 hydrogen. But one oxygen is on the reactant side, but on the product side there are 2 oxygen. That's why if you follow the summation here, you find out that on the reactant side, hydrogen 1 times 2, while oxygen is 1 times 2 also. On the case of the oxygen is 1 times 1, which is 1. But on the product side, you see that oxygen is 2, which is unbalanced because 1 plus 2 is not, 1 is not equal to 2. So to balance the equation, we introduce a 2 on the water and also a 2 on the hydrogen. Look at it now. Hydrogen becomes 2 times 2, 4 on the reactant side. And on the product side, 2 times 2 also 4. So 4 is equals to 4. Yes, it is balanced. Then oxygen also on the reactant side, because there's a 2 at the coefficients there, becomes 2 times 1, giving you 2. And oxygen on the product side becomes 2 times 1 times 2 equals to 2. So 2 equals to 2. Yes, it is balanced. Remember, in balancing a chemical equation, only the coefficients you can alter. You can't alter the subscripts because they are what makes up the formula or symbol of the element or compound, as the case might be. The next example is copper plus trioxonitrate 5 acid to give you copper 2 trioxonitrate 5 plus water plus nitrogen. Now, if you look at it, you find out that the equation is not balanced because on the reactant side, copper is 1. On the product side is also 1. But oxygen on the reactant side is 3. But oxygen on the product side is 8. How do we get 8? 2 times 3 plus 1 plus 2 will give you the 8 we are talking about. So it's not balanced. Hydrogen is also not balanced and nitrogen is also not balanced. Now, how do we balance it? If we introduce 4 in front of the triiodonitrate 5 acid, you find out that we also introduce 2 to the water on the product side and 2 to nitrogen 4 oxide. So let's look at it now after we have done our adjustment. You find that copper is 1 on the reactant side, yes. On the product side, copper is also 1. So 1 is equal to 1 on reactant and product. What about oxygen on the reactant side? It's equals to 4 oxygen times 3, making it 12. I hope you get why it is 4. You see, why it is 4? Because of the 4 we have introduced. So you can see 4 times 12 times 3 gives you 12. Now, if you come to the product side, you see that there is 3 times 2 oxygen. Looking at it from the product there, you can see the 3 in the bracket and the 2 outside. Then you now see 2 times 1 of oxygen. That means on water, there is 2 times 1 oxygen. And finally, we have 2 times 2 making it 4. So when you sum it up, you still have 12. So 12 plus 12 oxygen, it means oxygen is balanced. Then for hydrogen, you can see there we have 2 hydrogen times 2, making it 4. Also there we have 2 hydrogen times 2, making it 4. And lastly, nitrogen, as you can see, 4 times 1 equals to 4. And 2 times 1 plus 2 gave you 4. So 4 is equals to 4. And nitrogen is balanced in this equation. So the equation is balanced as we round up. You can also balance equation using fractions, such that we say C2H6 plus oxygen to give you water plus carbon 4 oxide. Now, if you look at the 3 times 4, you look at the balance, we say C2H6 is plus 7 divided by 2 oxygen, reacting to give you 3 molecules of water plus carbon 4 oxide. Now we use 7 over 2 to balance oxygen because the oxygen is 3.5 and there is no fraction in balancing. So if you want to remove the fraction, you multiply the equation all through by 2 and you will see that it is balanced. Then we will look at our assignment finally. The assignment says state the following laws. Laws of conservation of mass, law of multiple proportion, and the law of reciprocal proportion. Number 2, write an equation of the following reaction. A reversible reaction of nitrogen and hydrogen to give ammonia. And 2, the composition of zinc trioxonitrate carbonate 5 to give zinc oxide, oxygen, and nitrogen 4 oxide. Then balance the following equation. Phosphorus pentachloride plus water to give you phosphorus oxotrichloride plus hydrochloric acid. The second one is calcium tetraoxophosphate 5 plus tetraoxophosphate 5 acid. It give you calcium hydrogen tetraoxophosphate 5. Then the next equation is H2SO4 plus sodium hydroxide to give you sodium tetraosulfate 6 plus water. And lastly, iron plus oxygen to give you iron 3 oxide. We have come to the end of our lesson today. I hope you follow us in our next lesson. But remember, if you have any issues you want to raise with us, you can contact the following numbers. Mr. Philip Mamman, 08026598861. Mr. Ibrahim Umar, 07036202842. My wonderful student, have a wonderful time. Stay at home. Remain blessed. Keep the COVID-19 protocol. And I'll see you in my next class. Have a wonderful day.